Hi folks, welcome to another Cancha Geometallurgical software tutorial. My name's Adam and we're going to be talking about the new sample representativity functionality in Cancha 2.0 that's just come out. This is being recorded in December 2020. So without further ado, let's have a little look. We've got the Bonnie dataset open here, and I'm going to go to the samples area up here in the first toolbar. And then in the second toolbar, you'll notice a couple of new icons here. The first one is representativity, and the second one is sample selection. I'm covering sample selection in a separate video. For now, I'm going to be covering the representativity report. So choosing that report there, it gives us opportunity to choose a case filter. So there's a video that explains sample representativity, and suggest you look at that to see what a case filter is. Basically, it's the population of drilling that we want to represent by the samples. In this case, we just want to look to see, in pit. So in pit material, which is a filter that we've got here pre-established. That's going to be our focus case. And then we're going to choose which phases. Now, it could be that you have a whole bunch of phases, and you can choose whether you only want to include one phase or you want to include all of them. In this case, I only just have phase 6. So I'm going to choose that. And there's a bunch of features already populated. That comes about because it automatically populates the features that you're already using on the project in other areas like sample selection. But I'll just use this to get rid of that. And so we'll go ahead and go to drilling. So this only works for drilling. It can't be metallurgical samples. It can't be block model. So let's look, for example, at rock type we want to consider. Maybe on the assays, we want to look at, silver and gold grade. Maybe we want to look at iron and copper or something like that. And then maybe you want to also look at, maybe alteration. Okay. We can also use lookups. We could look up, for example, for in pit or out of pit from the DXF of the pit shell. And we also want to use the lookup from the block model. Maybe we want to see what the representativity of the in-situ bulk density was. And one more, let's go with the oxidation domains. So we've got a mixture of categorical and numerical features that we want to compare the representativity from. So once we've got our list, we just hit apply. This takes a second, and it gives us a table with exactly the features that we're talking about. And it's broken down by phase, sample ID, drill hole name, drill hole from and to, length, easting, northing, and RL of the centroid of each sample. Then the features, and this can of course be copied and pasted either as an image or as a text or whatever, or it can be exported as a CSV. So you can just hit this button here and copy and paste this table into Excel. If afterwards you want to add more features, no big deal. You can just go ahead and we could add sulfur afterwards just by dragging it in there. It's going to add sulfur to the breakdown. So that's the table view. Now I've switched to this split screen view. I've got I'm using this float button here on the main window to create a floating window for logs and a floating window for 3D. And they're on my second screen. You can also put them together on the same screen, whatever you want to do. Or even run with 3 monitors. If you've got 3 displays, you can see all 3 in their grandest glory. So basically, this table view here in the representativity report is interactive. If I choose a sample on here, it'll show me where it is in 3D, and it'll also show me where it is in log view. So now we go to plots. What it gives me here in the top line, it's always easting, northing, and RL. So it'll give me the distribution of the geographic location of each of these samples. The line indicates the distribution, the probability distribution of drilling intercepts in the east-west direction and in the north-south direction and the vertical axis. The dots on the line indicate the samples. So here we've got 30 samples in this sample selection that we did, and so we've got 30 dots on the list. And as we select one of the dots with the mouse, click on the left click, it'll highlight that in the mini map. It'll highlight it on the list here, and then also we'll get to see where it is in logs, and we'll also see where it is in 3D. So we can have a look at that in 3D there. And when we've highlighted it here on one graph, you'll notice that if I do a click there, it'll also show me where that sample is on all the other graphs as well. So for numerical information, you got that kind of graph. For categorical information, we got a regular histogram, where drilling is represented by frequency in drilling is represented by the orange bar, and the frequency in the samples is represented by the green bar. So here we can see that the samples are pretty well distributed across most of these things. We only looked at in-pit, so of course that was the case filter. So 100% for both the drilling and the samples are in-pit, because that was one of the criteria that we used. It is interesting here that it seems like argillic samples are subrepresented, or sorry, it's overrepresented. We've got more argillic material than we should have had, and we've got less silicification alteration than we should have had. So this is the sort of thing you can look at to see here whether your samples have got a problem with representativity. We see that the gold grade, the silver grade, and the gold grade are well distributed. We've got samples from the full range, but the iron grade, we don't have any very low grade samples, and we also don't have any high grade iron samples. So that's gives you cause for concern that you should, maybe look to see what these two domains are and why they haven't got any samples in them in this data set. Another way to look at the data is in 3D. So we get these little mini 3Ds in parallel. Basically, in the 3D view, it's just there's no drilling or block model. It's just the samples, and we can change the size of the sample bubble for each one depending on the size of the deposit. And we can also change the number of columns and rows depending on the screen size and whatnot. And so basically, here we can see copper, iron, gold grades side by side, and we can rotate them around like that so we can see how they compare with alterations and rock types and things like that. It's a super useful way to see how things are, clearly there's something going on with this hole over here. It's different in many respects, and it's the only one that has limestone. So that might be interesting, okay? Obviously every project's different. It's also the only one in OX2 domain, and it seems to have low copper and also seems to have a bit higher sulfur in this part of it. Okay, so those are the sort of things we can look at to see how the deposit works and how they're distributed in multi-dimensions. Finally, the other kind of way to look at the data is through these mosaic plots, where we see drill hole percentage distributions broken down in 2 dimensions for drilling and samples. So let's just look at one of these. Let's look at this first quadrangle here. This is silver broken down into its categories, which of course can be edited in the Legend editor. And here we've got the rock types, which are broken down by categorical information. So here, very low silver with basalt has 17% of the drilling. Very low silver in gabbro is 28% of the drilling. And when we see here in the samples, it's 23 and 23. So only 2% of the low silver things are in limestone in the deposit, in the drilling, and 7% in the samples. So this is a way, what you want to sort of look for is that whatever the distribution is here should be similar to the distribution here. It's never going to be the same. There's always going to be a difference. But what you're looking for is big deviations, like here, for example, where, missing some low iron in gabbro. We seem to have a lot of high, medium iron, but not low iron in gabbro. Is that important? That's your decision. Cancha is not prescriptive on what you should do about this, and every deposit is entirely different. But what Cancha does is it highlights the differences and gives you the opportunity to think about whether you've got representative samples or not. So those are the mosaic plots. If you want to change it, right now it's broken down by rock type. If you want to look at it, for example, by oxidation zone, I would just click on it here, and it'll give me these 4 oxidation zones from the block model lookup. And then I'd be able to see the breakdown by rock type and by silver and gold. So just by clicking on it, I get the pivot. Okay. So we think that these 4 things combined, we've got the table, which we can copy and paste and put out into a report or into a PowerPoint. We can put the plots into a report or into PowerPoint just by copying the image here. We've also got these 3Ds, again, can be exported. And we also have these feature mosaic plots pre-configured, so they can be compared. Again, can be copied and pasted. So all these things together are a way that you can rapidly check out the representativity, and by combining with the interactivity in 3D, by looking at, by choosing a sample and being able to see where it is in 3D, and then also look at logs, and then look at these sort of things in parallel, it's a great way to be able to visualize what's going on with your sample selection set and have a transparent and analytic assessment of representativity. So that is Representativity Report. Thanks.